Hi guys, welcome back. In this session, we're going to see some interesting questions about transformers, because as you know, for TSGENCO exam or upcoming SSC exam or maybe RRB exam, why I'm combining all these three exams, ఈ మూడు exams ని combine చేసి ఒక్కలా మాట్లాడదు ఎందుకంటే because more or less you can expect similar kind of questions, okay, conceptual questions. So that's the reason why we're talking all of these combined now. If I just focus on this for now, of course మనం ఈ లెక్చర్లో ట్రాన్స్ఫార్మర్స్ యొక్క questions చూద్దాం, but to tell you some of the key things about the exam, TSGENCO exam గురించి or be it other exams also, I strongly recommend you to go through the previous year questions, PYQs. Now from where, sir? From where I'll get the PYQs? Before I head to the MCQs, మీకు PYQs ఏ PYQs చూడాలి? TSGENCO, ట్రాన్స్కో అండ్ PDCL వీటిలన్నింటికి సంబంధించి, అంటే తెలంగాణ స్టేట్ ఎలక్ట్రిసిటీ బోర్డ్ నుంచి, గేట్ ఎగ్జామ్ నుంచి, ఓకే, అండ్ కేర్ఫుల్ గైస్, ఇస్రో ఎగ్జామ్ నుంచి, అండ్ ఎస్ఎస్సి ఎగ్జామ్ నుంచి, ఆర్ఆర్బి ఎగ్జామ్ నుంచి, జేఈ ఎగ్జామ్స్ నుంచి మీకు అందులో కాన్సెప్చువల్ క్వశ్చన్స్ ఉన్నాయి, మంచి కాన్సెప్చువల్ క్వశ్చన్స్ ఉన్నాయి. ఆ క్వశ్చన్స్ మీరు సాల్వ్ చేయాలి. సార్ సాల్వ్ చేయడం ఎలా సార్ అంటే, యూ కెన్ చెక్ ఇట్ అవుట్ ఆన్ ద నెట్ ఆర్ ఎల్స్ మన PiSquare వెబ్సైట్లో కూడా యూ కెన్ చెక్, డిస్క్రిప్షన్లో ఆర్ స్క్రోల్ అవుతున్న వెబ్సైట్ ఉంది కదా, అందులోకి వెళ్తే ప్రీవియస్ ఇయర్ క్వశ్చన్స్ సెట్ ఉంటుంది లోయెస్ట్ ప్రైస్లో విత్ డీటెయిల్ సొల్యూషన్. ఇట్ ఈస్ దేర్. ఆర్ ఇఫ్ యూ వాంట్ టు బై అ బుక్, సార్ నేను ఫిజికల్ బుక్ కావాలి సార్ నాకు అంటే, యూ కెన్ బై దిస్ బుక్ ఫ్రమ్ ద వెబ్సైట్. అగైన్ వెబ్సైట్ నుంచి యూ కెన్ get this book also, okay. So you will get this content with a detailed explanation, and that will be very much helpful for you. ఈ ప్రీవియస్ ఇయర్ క్వశ్చన్స్ అనేవి చాలా హెల్ప్ అవుతాయి మీకు. రివైజ్ యువర్ కాన్సెప్ట్స్ ఆర్ మేబీ లెర్న్ సమ్ కాన్సెప్ట్స్ ఆర్ బ్రిడ్జ్ సమ్ గ్యాప్స్. మీకు ఎప్పుడైతే గ్యాప్స్ ఉన్నాయో ప్రిపరేషన్లో, ఆ గ్యాప్స్ని ఫిల్ చేయడానికి కూడా ఇది చాలా యూజ్ అవుతుంది. ఓకే, ఎనీవేస్ దట్స్ ఎండ్ ఆఫ్ the intro part of how we should prepare. Now let's dive into the questions. Okay, coming to the first question, I want you to answer these questions. Okay, I want you to answer these questions. Kinda meeku timer is running. Okay, 55 seconds undi inka, so go ahead. Anuja had a question. Okay, so I want you to respond in the chat. Again, those who are responding, if I like your responses are really good, me responses ganaka baunde, you will get this book free. It will be delivered to you for free of cost. Okay, so last time alage I think Sampath has won this book, so that's a giveaway of this session. This book you will be getting it. Yeah, I think like every time we're starting off with a simple question. మనం స్టార్ట్ అయ్యేది సింపుల్ క్వశ్చన్ నుంచి స్టార్ట్ చేసాం. ప్రశాంత్, వెరీ గుడ్ ప్రశాంత్, గుడ్. Nice. Keep it up. So చెప్పిన కదా ఇందులో మనం డిస్కస్ చేసేది థియరిటికల్ క్వశ్చన్స్ ఫ్రమ్ ద previously asked a question from different exams. This is one of the questions asked in ISRO. Okay. Ramesh, I think everybody said correctly. Your time's up, by the way. So let's see. Transformer core is laminated. We're starting off with the easy question, right? Laminations ఎందుకు చేస్తాం core ni? They're laminating the core because it's difficult to fabricate solid core. No, it's not difficult to fabricate solid core. It's easy. Because laminated core provides high flux density, not really, to avoid the eddy current and hysteresis losses. This is not exactly correct. Okay, we don't laminate for hysteresis, but the only relevant option out of all these is C only, because we laminate to reduce eddy current, that's for sure. Okay, we laminate to reduce the eddy current, that's for sure. So, but hysteresis is not actually right. Okay, it correct kaadu. But out of the listed options, this is the only option which is relevant, so I'm opting for it. I don't have other choice. Moving to the next question on the screen. Prashant, really good. Prashant Reddy has explained nicely. Eddy current is inversely proportional to the current. I think resistance you wanted to say maybe. A laminated core increases resistance, very good, because it reduces area of cross section. Sampath, I think he's the person who won last time the book. Okay, this could be you this time. The physical book. This book will be delivered to you, your address. If you respond, obviously you have to respond. And if I like your responses are really good, then not everyone, to one person, right from the beginning to ending, who is responding, to that person will give this book. And you know, it will be very beneficial. And you can buy this book. This book, the price is 700 is the price of this book. Okay, I think you can get it from our site for 400 or something. Okay, time's up. Let's see. Two transformers operated in parallel will share the load depending upon their. Careful, guys. Strictly speaking, when you connect two transformers in parallel, they should share the load based on the ratings. They should. Okay, they should. But in order to do so, who is the factor which is in control? Who is controlling whether they are proportional to ratings or they are with respect to the rating or something? Who is the key factor which is doing that? The factor which is doing is per unit impedance. This will ensure the load sharing is as per the ratings. Okay, మీకు ఆప్షన్ ఏ ఇది ఇచ్చాడు కదా ఇది మార్క్ చేశారంటే గాన్. ఓకే, ఆప్షన్ ఏది ఇస్తే అది మార్క్ చేయకండి. అంటే ఫస్ట్ ఆప్షన్లో ఉంది కదా సార్, ఇచ్చారు అనుకోండి అంతే అయిపోయి. Instead, what you should do is you should understand what is asked. Okay, so per unit impedance ni batti ratings ద్వారా వెళ్తుంది. Answer is D. I think mostly you guys have answered it correctly. That's good. It's for everyone. I'm moving to the next question. Yes. Let's see who is going to answer this. Let's see who is going to answer this question. Getting mixed answers for this. Okay. Invisible city is saying B. Okay. See guys, ఈ క్వశ్చన్ బేసిక్ క్వశ్చన్ ఇది, and you're gone. And none of you answered correctly actually. That's really strange. Wow. Sainath, Sai Ganesh. Sai Ganesh, he is right. He is right. Give that heart to this guy, Sainath. Sai Ganesh. Okay. Send the hearts to him. Yes, dear Sampath, you're right. It's a ratio of, guys, transformer low. You call it as a transformer or maybe induction machine. E dispersion coefficient or dispersion ratio, one will call, they represent with sigma. Sigma, dispersion ratio or dispersion coefficient. It is a ratio of magnetizing current I mu, magnetizing current I mu to the short circuit current, to the short circuit current under ideal conditions. Now, if this dispersion coefficient is low, what does it mean? What does it mean? About the power factor, tell me about the power factor. How this dispersion coefficient and power factor of a transformer are related. I think with this expression itself you can ask, you can say, this expression itself is pretty much clear. With that you can say, yes Sampath, you're absolutely right buddy. It will increase the power factor. Means it's not it will increase the power factor, it means lower dispersion factor means it implies high power factor. Okay, that's very good. Keep it up. Keep it up. Others, guys, that's what happening. You know, you're not aware of the questions, what kind of questions they're asked. You have to know all of these. You appear the previous questions. Online maybe from our website or maybe from this book. You get it, guys. Come on. Or maybe online, just jump onto online. Get the questions, spool the questions, try to answer it. Learn from those questions. In the classroom, you will only get the knowledge to understand these questions. Different kind of questions you'll be getting by answering a lot of questions from outside. Anyways, moving on to the next question. Bang. I think it seems today you got a little tougher questions than I think you guys are not understanding. I mean, not able to answer it, I think, because the level has increased a bit from the previous session. So I think you guys have stumbled. That's not what is expected. Huh? Okay, I think your time's up. Few answers. That's really strange. I don't know what kind of difficulty you're feeling from this. Let's see. A transformer on no load is switched on. See guys, క్వశ్చన్ మీకు ఎప్పుడైతే లెందీగా ఉందో జనరల్గా మీ మైండ్ ఏం చెప్తుంటే అరే బాయ్ లెందీ క్వశ్చన్ వస్తుంది రే బాయ్ నేను చదవలేనేమో. నో మ్యాన్, యూ గాట్ ఎ లెందీ క్వశ్చన్ మీన్స్ just by reading the question you will be able to answer it. And GENCO వాటిల్లో మీకు 1 minute 1 question, so definitely they will not test your critical thinking, they will test your conceptual understanding of the questions. There are different levels of question setting. Critical thinking questions ఉంటాయి, analytical questions ఉంటాయి, basic and conceptual questions ఉంటాయి, మీకు ఇలాంటివి వస్తాయి. Coming back to this question, ట్రాన్స్ఫార్మర్ అనేది నో లోడ్లో ఉంది అండ్ ఇట్ ఈస్ టర్న్ ఆన్, స్విచ్ ఆన్ చేశారు నో లోడ్లో ఉండగా. ఓకే, to a source of a voltage, some source of a voltage, some voltage ki maybe let's call it as 230 volts. This is, guys, this is one of the interview questions, one of the popular interview questions. Okay, popular interview question. It will draw, there is a concept behind this. Can somebody tell me what is this concept? Can somebody tell me what's the concept behind the question? This a transformer on no load is switched on. ఆ ఒక్క మాటతో, ఆ ఒక్క వర్డ్తో మీకు ఒక కాన్సెప్ట్ గుర్తు రావాలా? ఎస్ సంపత్, యూర్ అమేజింగ్. దాట్స్ అ కాన్సెప్ట్ కాల్డ్ ఇన్రష్ కరెంట్స్, ఆర్ యూ కెన్ కాల్ ఫ్లక్స్ డబ్లింగ్ ఎఫెక్ట్. Flux doubling effect or inrush current, they are related. So that mainly depends on, you cannot really say what kind of current it will draw, whether it will be low or it will be high. It is subjected to the condition of the transformer. To be more precise, it is subjected to what residual flux it has at what instant of the voltage. 230 volts is not a constant, right? It's a nice, amazing sinusoid. At what instant of this voltage you're closing the switch, what is the residual flux it is having? Based on these aspects, that current will be depending on those aspects. Okay, so several times which is same as steady state magnetizing, and that's definitely not true. It's not same as regular current, which is several times a steady state magnetizing current depending on the initial state of the residual flux in the core. Yes, this is absolutely right. This is absolutely right. Guys, ఈ క్వశ్చన్ ఆన్సర్ చేసే ప్రాసెస్లో ఇది ఐ థింక్ 2000 మేబీ 15 ఆర్ 17లో తెలీదు, ఇస్రోలో ఇచ్చిన క్వశ్చన్ ఇది. ఓకే, ఈ క్వశ్చన్ చదువుతుంటేనే మీకు ఒక కాన్సెప్ట్ మొత్తం అంత ఈ క్వశ్చన్లో ఉంది. యూఆర్ నాట్ యాక్చువల్లీ ఆన్సరింగ్ ద క్వశ్చన్, యూఆర్ understanding the concept with the help of this question. I hope you got the point. Moving to the next question. Easy peasy, this is easy one, right? Come on. What are you up to, guys? It's pretty slow response from your end. This much time for this question is not expected, huh? Only Sampath has been answering nicely. Not correct? Okay. Guys, this is not enough. Your preparation is, I think, not up to the mark. That's what I can feel. Because the responses are really slow. కాంపిటేటివ్ ఎగ్జామ్కి ప్రిపేర్ అవుతున్నట్టుగా లేదు రెస్పాన్సెస్ మీది. కాంపిటేటివ్ ఎగ్జామ్స్కి ప్రిపేర్ అవుతున్నట్టు రెస్పాన్స్ ఎలా ఉండాలి? మరి ఒక్క దాని తర్వాత క్వశ్చన్ అడగడం పాపం ఆన్సర్ రావాలా, అలాంగ్ విత్ ఎక్స్ప్లెనేషన్ రావాలా. ఎస్ రైట్, బట్ మీకు I don't know what's going on. Okay, the time's up. Let's get to this simple one. This simple one, a simple one kuda meer anta time తీసుకుంటారా? The applied voltage of a certain transformer is increased by 50% while the frequency is reduced by 50%. the maximum, come on, yeah, this is maximum flux density, that's is equal to, or that's proportional to V by F, voltage by frequency. Now, voltage has increased by 50%, so let's take it as 1.5 times has increased. And frequency has reduced to 50%, means it was earlier 1, now it is 0.5. The change in flux density is 3. Wow, Sai Ganesh has given that part also. Yes, it is 3 times. 1.5 by 0.5 is 3 times. Okay, Sai Ganesh, good one, buddy. This is for you. Moving to the next question. Yeah, guys, you should also encourage the one who is giving such nice answers. Okay, let's see. ఈ క్వశ్చన్ తర్వాత I want everybody to chant one name. Whoever answers questions first, all of you have to chant his name. I mean, all of you have to chant his name. Okay, the one who answers the first. Who answers correctly first. That makes sense, right? Wow, what happened? Everybody's saying dry type, dry type. Can somebody tell me what is this dry type? It's not quite expected. Just punch in, what do you think? What's a dry type transformer? You answered it, I think, out of the fanciness. You know, what is this? ONAN, not onion. ONAN full form. Somebody can give it. ONAN full form. Yeah, go on. ONAN transformer. What is ONAN transformer? Or maybe what is this ONAF transformer? What is this OFWF transformer? Wow, Sai Ganesh, good one. Good one. Others? Other parts also? It is oil natural, air natural. What is this oil natural, air natural? The type of cooling which is there for the transformer is oil transformer, and to cool that oil, air is circulated outside. That's called, they're called as a fins. Okay, so that's what natural circulation of the oil is happening, and natural circulation of the air is happening at the surface. So the flow of oil, flow of air is very natural. You're not forcing it. So it needs little more space. It needs larger surface area, to be more precise. Okay, it needs larger surface area, to be more precise. So comparatively, this is not, it is asked for same electrical specifications, the smallest size. By nature itself, it needs larger surface area, so this cannot be answered. So when I say this, the most opposite statement for this is this one. What is this? Oil forced, water forced. Of course, you may say air forced is definitely when you're circulating the air as well as the oil, natural oil. This is not oil forced, oil natural, air forced. Naturally, oil is circulating. You're forcing the air by fans, by keeping fans. I think in our regular course, మన కోర్సులో a nice animated image తో 3D image తో చూసాం. ఫ్యాన్స్ ఎలా ఉంటాయి కింద, కోర్ ఎలా ఉంటుంది లోపల, ఆయిల్ ఎలా ఉంటుంది లోపల, అంతా 3D image తో మనం కోర్సెస్ చూసాం. దేర్ ఐ ఎక్స్ప్లెయిన్ ఆల్ ఆఫ్ దీస్. ఓకే, ఐ థింక్ మీ అందరికీ తెలిసిందే ఉంటుంది, చెప్పాల్సింది పనిలే. చూస్తారు ఒకసారి ఏం చెప్పాలనుకుంటున్నాను, వస్తే చూడండి. What I want to say is about our courses. PiSquare courses లో మీకు ఇండియాలో Yeah, chalo. ఇండియాలో మీరు ఎలక్ట్రికల్ నేర్చుకోవాలి, యానిమేషన్స్, అమేజింగ్ బ్యూటిఫుల్ యానిమేషన్స్ నేర్చుకోవాలంటే ద ఓన్లీ ప్లాట్ఫామ్ యూ హ్యావ్ ఇస్ PiSquare Academy. ఓకే, ఎనీవేస్, సో అందులో మనం డిస్కస్ చేసాం క్లియర్గా. ఆయిల్ న్యాచురల్, ఎయిర్ ఫోర్స్డ్, దీనికన్నా కొంచెం తక్కువ సైజ్ ఉంటుంది ఫర్ షూర్. బట్ ఇంకా తక్కువ సైజ్ ఉండేది ఆయిల్ కూడా ఫోర్స్గానే సర్క్యులేట్ చేస్తున్నాం, ఎయిర్ కాదు. W stands for water. Yeah, the most dangerous thing in electrical engineering is water, and you're using that most dangerous thing, you're utilizing to cool it down the transformer. That's the power of engineers, man. Okay, the danger you're becoming into the advantage. So as you're forcing the oil, as you're forcing the water, not inside the transformer of course, outside the transformer, using water to cool it down. So definitely it cools much faster. It doesn't have to have such a big surface area. So this is what the smallest of all. Now coming to this dry type transformer, I think when you hear this dry type transformer, you might be really fancy because all of you picked this option for answer as B, you opted for, but this is wrong. In dry type transformer, for the same capacity, there is nothing inside. I mean, there is no oil, it's a completely air is there. And it's not having such a great cooling properties, man. Air is not having such a great cooling properties. So definitely that cannot be the answer. Okay. So for the same capacity, you have to keep that same electrical specifications. So answer is this. So this is also ISRO question. Okay. I think none of you could answer it within the time. So yeah, we're moving to the next question. I think easy one, huh? Okay. Time's up. Let's see. R proportional to 1 by A. Very good. I think this has been addressed already in the first question rather. The eddy current loss in a transformer will be reduced if number of turns in a transformer primary. No, not related to number of. Reduced if the laminations are thick. No, if the laminations are thin. This is wrong. Laminations are thin. Contrast to this. Answer is D. Who said answer D first? I think everyone said, but the first one who said is Praveen. I want you to punch in the name Praveen in the chat. Everyone, punch in Praveen in the chat. See how nice you are. You're not even encouraging the guy who is answering. Such a crazy people you are. I know. मुझे जानी चाहिए दादा. हाँ, that kind of encouragement should be there. At least हाँ, दो लोग तो बोल रहे भाई. Good. Moving on to the next question. Good. Praveen Naik. Nice guys. Yes, Praveen, you deserve it, man. Yeah, that's good. He's sending thank you for all of you guys. That kind of spirit must be there among you at least, huh? If that is not there, then what for, man? You don't answer and you don't encourage the person who is answering. You don't get inspired. You don't get that sportive feeling. What's the point of it? Huh? Yeah, let's see. The buckholes relay is used to protect. Time's up? No. I think this is maybe మన PiSquare ఛానల్లో రిలీజ్ అయిన early stage of videos one of the first videos is buckholes relay, which is one of the popular videos also. First stage early stage లో వీడియో ఎందుకంటే గ్యాస్ యాక్చువేషన్ ఎలా జరుగుతుంది ఏంటి ద ప్రాసెస్ ఆఫ్ ద క్లియర్ ఇండికేషన్ ఆఫ్ హౌ ద buckholes relay works. You call it as buckholes relay, butchholes relay, what are the name, man. So this is used to protect what? Protect the transformer, because it's an oil actuated, oil immersed transformer. In oil immersed transformer, it's a gas actuated relay, that's true. In oil immersed transformer against all internal faults, that is right. In oil immersed transformers only, because it's basically a gas actuated relay. So yes, it must be immersed in the oil. Then it releases, when the internal fault happens, it releases gas bubbles that will activate the relay. అమేజింగ్ యానిమేషన్ ఉంటుందండి. బక్హోల్స్లో PiSquare అకాడమీ కొడితే మీకు బ్యూటిఫుల్గా మేబీ ఒక 7 minutes ఆఫ్ వీడియో ఉంటుంది. ఆ వీడియో చూస్తే కంప్లీట్ డీటెయిల్స్ అర్థమవుతాయి మీకు. ఓకే, లేదు సార్ నా సాగు నేను చేస్తానంటే మీ సాగు మీరు రావాలి. Mercury switches and all. Yes, you're right. That's also a good keyword. Now who answered first this time? It is Invisible City. What's your name, Invisible City? Okay, let's name him as City. City, all of you have to type City in the chat. City in the chat. That's the way you're actually Shiva. Okay. So that's the answer. Only Ganesh is encouraging this guy, huh? Others? Yes, that's good spirit. That's good spirit. Just regarding with dry type transformer, loaded 100%, but other type transformers 80%. Okay. Moving on to the next question, guys. It's good. I really appreciate your efforts in encouraging others also, guys. Keep it up. Keep it up. And the best part is, who is not answering the questions also encouraging the guys. That's a really sporty thing. I think Santu is, he didn't answer it, but he's answering. He's appreciating. No, he's answering Santu actually. That's good. At least you should appreciate the efforts of others. Yeah, time's up. Time's up. Okay, what is this? Why are the transformers stamping annealed? Stampings, transformer stampings, transformer laminations. What is this annealing? Annealed laminations. What does it mean? Annealing is a process. It's a heat treatment process and has the magnetic properties of the transformer core, improves the efficiency and performance. It's basically heat treatment process of the core. Okay, so that will, I think no one answered it. Huh? So nobody knows this annealing process. I think maybe I'll give how many of you using our GPT PiSquare AI? How many of you tested it? PiSquare AI, where we trained the bots with the electrical knowledge. I think we नहीं दिया सबको. अच्छा. We'll give it shortly. Hardening process, very good. It's a heat treatment process, very good. Okay. Nice, annealing hardening process. Good, guys. So why we're doing this? The question is that to give mechanical strength to the core, to increase the core permeability, reduce the hysteresis losses due to burning of edges. No, it is to reduce eddy current losses. I think you must have heard this annealed copper also is there. Annealed copper, people will, I mean, there is some material, different places. I think in materials, you'll understand all of these. I think, how many of you understood materials? Did we launch materials? No, it is there within our course, regular course. Okay, regular course, it is there with the nice animations once again. That core structure or atom structure and all, with the 3D animations and all, you got that material science course, material engineering for TSGENCO. Okay. Anyways, coming back to this annealing is done to reduce eddy current losses. Okay, so answer is A, Brahmteja used in coating. Okay, that's good. Next one. I think this everybody will be able to answer it because this is easy one. Huh? Strange. I got some mixed answers, I think, to the previous one maybe. Okay, I think everybody answered it correctly. That's great. Really good. The first one to respond to this question correctly is Aishwarya. Okay, punch in the name Aishwarya. Everyone say Aishwarya. She's the one who's first who answered it correctly. As compared to delta delta bank, the capacity of VV or open delta of a transform, open delta bank of a transformer is open delta delta. You have 3 transformers. In open delta, how many transformers are there? Come on. In open delta, how many transformers? Only one person is encouraging. Others, what happened? That's not fair, guys. In open delta, how many transformers? 2 transformers. At least give a short name, Aish or whatever it is. That should be done if you're lazy in typing all of this. At least I is also okay. That's good. That's a way of sending your love or whatever it is. 2 transformers. Suppose if this is handling 100%, this should handle 100 by 3 into 2, which is a 66.6%. So answer is B, wrong. If you just use this unitary method, you will not get a right answer. You should not apply that logic here. You know why. You know all the details, I think. When you are dealing with open delta, yes, the 2 transformers are underutilized. They are underutilized. They're not up to their own capacity. Tell me, if you are using these 2 transformers, means you are putting, by applying a unitary method, if you apply this much percent of load, then these 2 transformers will be overloaded by how much percent? The question is clear? By how much percent these 2 transformers are overloaded if you apply this load? Am I clear with the question? Regarding the Scott connection or open delta connection, these are the 2 different things. Based on these numbers will be asked. They are really simple, interesting numbers. You have to play with those. Okay. And if you miss it, I want you to refer your books. And if you want any free material, no sir, I cannot even spend the 500 rupees for this amazing content what you have. You cannot even spend 500 rupees. You're okay to eat biryani by spending 1000 rupees, but you're not ready to spend 500 rupees for your career. It's okay. You chat us in the WhatsApp, sir, I want free. Write the name free courses. We will send the best available free courses in the market. We'll give it to you. Okay, you eat biryani, waste your money in the biryani and at least enjoy the free courses. Don't feel shy to type free courses I want. Okay, at least that. Point is, you have to answer these kind of questions, man. Otherwise, what the hell is your preparation is happening? I don't think your preparation is up to the mark. Huh? You should pump up your preparation. In the description, WhatsApp number is there. Click there. It will take you to that. And punch in free courses for this subject. It's not that PiSquare course you will get it for free, but the best available free courses will give it to you. Okay. So answer is, this is the answer for this question. Gain some more knowledge from this. Okay. Moving to the next question. Here you go. Okay. Time's up. Who answered it correctly? Such a straightforward question. Such a straightforward and the easiest question of all the questions what we have seen so far. And మీకు vector grouping గురించి తెలియకపోతే, if you don't know vector grouping, which is a critical concept, believe me, PiSquare vector grouping, you just type in this YouTube, this keyword, vector grouping PiSquare, or vector grouping of a transform PiSquare, with amazing animations. You will understand inch by inch every part of this vector grouping, which is a crucial part for understanding three-phase. To answer any of the questions of three-phase, you watch that maybe 20 minutes of video, it will change the way you understand vector grouping, believe me. Okay, just watch it on YouTube, it's available. Okay, good. Yeah, I'm talking about, I think Vanajay is trying to say something. Be it Scott connection, be it open delta connection, the numbers are important there. That's what I'm trying to say. Here, coming to this, on two sides of star delta transformer, the voltage currents both are in phase. Two sides. They're talking about both the sides, primary and secondary. Primary and secondary. They're talking about this. Okay. Now we know, can somebody punch in what kind of, I think already has given it. Sampath he is a rock star. Okay, he already answered my question. I didn't ask the question, he answered actually the question. The question is, send some hearts to this guy, man, Sampath के लिए. संपत के लिए जरा से हार्ट तो भेजो. साथ तुम लोग तो कुछ नहीं करते हो. हाँ, ये तो लड़का स्मार्ट है. So what are the other all possible combinations for star delta? All possible combinations of star delta. Vector grouping, what are the clocks? YD, YD1, YD3, YD5, YD11. These are the possible vector groupings. What does it mean? There is a phase angle difference. If you refer these two, 30 degrees in one case leading, another case lagging. 30 degrees is this case, and this is, I think, a 3-5. No, not 3-5. Not 3-5. It's 5-7. It's 5-1-5-7. Then it is 150 degrees. 150 degrees leading and lagging. So here, they didn't give anything about 150 degrees, but they gave something about 30 degrees. So this is wrong answer. Voltage and currents both differ in phase by 30 degrees. Absolutely right. Let's just check it out the other options. The voltage differ in phase by 30 degrees, but current are in phase. No, man. If voltage is changing, let us consider there is no, I'm talking about ideal transformer because it's not mentioned. So let's take it ideal transformer. Current cannot be within phase. Current also will differ. If it is not ideal transformer, the no load transformer power factor will add up to that, add up to the load power factor. Okay, we cannot say they will be in phase. Currents are in phase. So in any way, this in phase concept is not correct. The currents differ in phase by 30 degrees, but voltages are in phase. No, not at all. Voltage anyways out of all these configurations means మన voltage యొక్క primary, secondary or high voltage, low voltage, to be more precise, high voltage to low voltage phase angle, voltage ki phase angle different గా ఎంత ఉంటుంది. So this is a definite wrong answer. This is a definite wrong answer. Now when it comes to current, current also will differ by some phase angle, definitely not in phase. So this is also wrong answer. The only right answer is this. And you have to remember this. Believe me guys, మీరు యూట్యూబ్లో ఫ్రీగా అమేజింగ్గా ఉన్న ఆ వెక్టర్ గ్రూపింగ్ కాన్సెప్ట్ చూస్తే మాత్రం అదిరిపోతుంది. మీరు చూడరు. ఎందుకు చూడరు అంటే మీకు సంకరానికి పోయే టైం వచ్చింది, మీరు చూడకండి. నెక్స్ట్ క్వశ్చన్ ఆన్సర్ చేయండి రా అట్లీస్ట్. చదువుకోండిరా అంటే చదువుకోరు, జబర్దస్త్ చూడండి రా అంటే చూస్తారు. చూడండి రా బాయ్, జాబ్ కావాలి అందరికి, చదవండి రా అంటే ఒక్కడు రాడు ముందుకి. జాబ్ మాత్రం కావాలా? అరే ఇవ్వ నీకు ఎందుకు ఇవ్వాలి రా బాయ్ జాబ్? చదివితే నీకు వస్తుంది, నీకు ఎవడ ఇవ్వగల. నౌ కమ్స్ squad connection. Vanaja, I think your favorite one. You've been asking a lot about this, I think, in the chat. Now it's here, buddy. I think today's session, live session, has been postponed a lot of times. Huh? Answers, guys. What are you up to? This much time? Inta time? खूब time log je. Prashant Reddy, Prashant Neil. Who is the director of Salar movie? In the chat. Only the first name, not the last name. Only the first name. First name Salar director. Nobody knows. It's this guy, Prashant. Anyways, your time's up, guys. The Scott connector transformer. I think, guys, ఇంకొక పాయింట్. అసలు ఈ స్కాట్ కనెక్షన్ ఏంది సార్? ఈ స్కాట్ ఎవడ సార్? ఈ స్కాట్ కనెక్షన్ ఏంటి సార్? 3 phase నుంచి 2 phaseకి మార్చడం ఏంటి సార్? అసలు వీడికి బుద్ధి ఉందా లేదా సార్? స్కాట్కి ఏం చేస్తున్నాడు సార్? మనం వాడిదేమో 3 phase ఆయే, మన ఇంట్లో వాడిదేమో సింగిల్ ఫేజ్ ఆయే, మనకు వచ్చేదేమో 3 phase ఆయే. మధ్యలో ఇక 2 phase ఎక్కడి నుంచి వచ్చింది, ఎందుకు వచ్చింది? అఫ్ కోర్స్ హీటింగ్ అప్లికేషన్స్ ఇవన్నీ ఏదో చెప్తున్నారు పర్పస్ఫుల్గా, బట్ అట్లా 3 phase సరిపోతే ఏంది? సరిపోదు కదా. ఈ స్కాట్ కనెక్షన్ కథేంద్ర బాబు అని చాలామంది బుర్రబాదుకుంటారు. దాని డీటెయిల్డ్ ఎక్స్ప్లెనేషన్, అసలు స్కాట్ కనెక్షన్ యొక్క క్రియేటివిటీ ఏంటి, అసలు ఏమన్నా స్కాట్ క్రియేట్ చేశాడు, ఎందుకు క్రియేట్ చేశాడు, క్రియేట్ చేసిన అవసరం ఏమొచ్చింది? 3 phase నుంచి 2 phaseకి, 2 phase నుంచి 3 phaseకి కన్వర్ట్ చేయాల్సిన అవసరం ఎందుకు వచ్చింది? మీకు తెలియాలంటే ఒక 20 minutes వీడియో ఉంది భయ్య, వై 50 hertz ఇన్ ఇండియా అని. వై 50 hertz ఇన్ ఇండియా అని ఒక వీడియో ఉంది PiSquare ఛానల్లో. మన వై సిరీస్ పాపులర్ వీడియో ఇది. మీకు ఎవడో చెప్పడు ఆన్సర్. ఒక్కసారి చూస్తే ఈ స్కాట్ ఎవడు, వీడు ఎందుకు వచ్చాడు, కథ ఏంటి, మీకు బొర్ర పాడైపోయి రిజల్ట్స్ అన్నీ వస్తాయి. 20 minutes వీడియోలు ఉన్నాయి, అమేజింగ్ ఉంటుంది. రైట్ అవుట్, యూ అండర్స్టాండ్ ద బ్యూటీ ఆఫ్ దిస్ గాయ్ స్కాట్. Coming to the answer, there are 2 transformers used in the Scott connection. What is the first? First one is main transformer, which is a center tapped, and Scott or a teaser transformer or teaser transformer. Now we're talking about teaser transformer. Scott can turn number of in teaser turns, primary and teaser turns respectively. Primary ki teaser ki ratio adugutunnadu. So clear ga primary transformer or main transformer and a teaser turns. Teaser transformer యొక్క turns తక్కువ ఉంటాయి. How much time? It is √3 by 2 times, and somebody nicely said 0.866 times. Okay, so if it is n, answer is this. Primary లో 100 ఉంటే teaser లో, primary అంటే main transformer లో, teaser లో √3 by 2 times of n, which is 86.66 turns దగ్గర మనం ట్యాపింగ్ తీసుకుంటాం. Of course 0.66 దగ్గర ట్యాపింగ్ తీసుకోవడం ఏంటి సార్, ఫులిష్. Close to that. Okay, దాంట్లో ఎందుకంటే ఇంటీజర్ వాల్యూ ఆఫ్ నెంబర్ ఆఫ్ టర్న్స్ కదా మనకు కావాల్సింది. Yeah, not at the decimal points we cannot take the tapping. The answer is this. I think you got it right. So ఇక్కడ పాయింట్ ఏంద్రా బాయ్ అంటే అండర్స్టాండ్ ద క్వశ్చన్. ప్రైమరీ అంటే ప్రైమరీ వైండింగ్ ఏంది, ప్రైమరీ అంటే మనకి ఇమ్మీడియట్గా స్ట్రైక్ ఏదంటే ప్రైమరీ వైండింగ్. సరే ప్రైమరీ వైండింగ్కి సెకండరీ వైండింగ్కి ఇది కదా రావాల్సింది, ప్రైమరీ ఇలా ఉంటుంది సెకండరీ ఇలా ఉంటుంది కదా, ఇదేంటిది అనవసరంగా కన్ఫ్యూజ్ అయిపోయి ఆన్సర్ ఇదా సిఆర్డి అని కన్ఫ్యూజన్లో సి పెట్టి ఇదంతా కథలన్నీ ఎందుకు పడతారంటే క్వశ్చన్ తీరం లేక, క్వశ్చన్ చదవ రాక, క్వశ్చన్ అర్థం చేసుకోవడం రాక. It is said transformer the number of primary and teaser turns. There you have to understand primary transformer, main transformer and teaser transformer, teaser turns. ఇది ఎప్పుడైతే మీరు అర్థం చేసుకున్నారో కథ వేరేలా ఉంటుంది. ఓకే, నెక్స్ట్ క్వశ్చన్. Happy birthday to Volta. Is it? That's great. Let's ask Google. Volta birthday.
Here are some pictures that match.
It's not matching. Volta birthday.
Alessandro Volta was born on the 18th of February.
Wow, yes. It's confirmed. I think Sai, you're right. It's great. Volta, volts, the unit volts birthday. I think kahan se aaye this guy? These guys. Mana Kakinada. Okay, I think time's up. The use of higher flux density transformer design. Yeah. Flux density perige koldi area of cross section of the transformer reduces. Okay. So the weight reduces. The weight of the transformer reduces. So naturally the answer is total weight per kVA reduces when you go for higher flux density. That's the reason why, of course, there is some issues with the losses and all, but definitely there is an advantage with respect to the size. Size is one of the key aspects. Size and weight and all, these are the key aspects that will bring the weight down when you're using high flux density transformer. Okay, guys, great. So for this great point, what I think Sai has said about the birthday of our amazing Volta, what to say? Okay, we'll give some gift to Sai some other time, and then maybe in the next live, if he is there. I'm moving on to the next question for now. Yeah. Area of cross section is inversely proportional to the flux density. For a constant power. Good, Ganesh. Very good. Wow, he's been too fast, man. This guy Sai, I think, is doing pretty good. Brahmteja, good. That's the spirit, guys. Now the pickup has come to you, I think. That's good. Keep it up. Thumbs up. Good, guys. Most of you answered correctly, but the one who answered this correctly first is Sai. Sai, this guy from Kakinada, has answered it first. So I want you to punch in the name Sai in the chat. If you're lazy, at least S also works. Yeah, come on, guys. Power input a transformer on no load at rated voltage. Rated voltage దగ్గర ఉందిరా బాయ్. No load లో ఉందిరా బాయ్. Copper losses, Zuzubi, very less because it's on no load. Eddy current hysteresis will be present. Predominant is not this and this, some of these two, which is a core loss. Core loss, which is a predominant case. Okay, great. I think Sai has many followers. Volta Sai, yeah, that's good. I think Brahmtej has combined the Volta and Sai. That's good. Sai, I think you got good followers, man. Keep it up. Next question. Because we got nice responses for Sai at least. Because the name is short or whatever the reasons, I don't know. The guy is amazing. Yeah. Go on to the last question. Let's wind up this question with this session with this. Of course, I have a few more questions, but I think I'm exhausted. I'll wind up here. Yeah, thumbs up. It is a distribution transformer have a core losses. See, మనం చూస్తే డిస్ట్రిబ్యూషన్ ట్రాన్స్ఫార్మర్కి అండ్ పవర్ ట్రాన్స్ఫార్మర్కి డిస్ట్రిబ్యూషన్ ట్రాన్స్ఫార్మర్ ఏం చెప్పాము? డిస్ట్రిబ్యూషన్ ట్రాన్స్ఫార్మర్ యూజువల్లీ ఆపరేట్స్ we'll design distribution transformer to operate at maximum efficiency somewhere around at 50% of the full load around. అంటే ఏంటి, డిస్ట్రిబ్యూషన్ ట్రాన్స్ఫార్మర్ ఎప్పుడు ఫుల్ లోడ్ దగ్గర ఆపరేట్ అవ్వదు. ఓకే, ఇందులో కోర్ లాసెస్ గురించి మాట్లాడుతున్నప్పుడు కోర్ లాసెస్ విల్ మేక్ షూర్, బికాస్ కోర్ లాసెస్ ఇది ఎప్పుడు ఫుల్ లోడ్ మీద ఆపరేట్ అయి ఉండదు. 50% లోడ్ దగ్గరే ఆల్మోస్ట్ మోస్ట్ ఆఫ్ ద టైమ్స్ ఆపరేట్ అయి ఉంటుంది. అలాంటప్పుడు మీరు ఫుల్ లోడ్ కాపర్ లాసెస్ తగ్గించే ప్రాసెస్లో కోర్ లాస్ పెరిగిపోతే యూజ్లెస్ కదా, ఎందుకంటే 24/7 ఉండే లాసెస్ ఏంటి? కోర్ లాసెస్. ఎందుకు? ఇది ఆపరేట్ అయ్యేది ఫుల్ లోడ్లో, తక్కువ ఆపరేట్ అవుద్ది కాబట్టి. సో యువర్ ఆబ్జెక్టివ్ ఇస్ టు మినిమైజ్ ద కోర్ లాసెస్. Minimize the core losses so that you are ensuring the maximum efficiency is coming somewhere around at 50% or maybe 60% or maybe 70%. Within this range, you are getting a maximum efficiency for a distribution transformer. So you will ensure the core losses are much less than the full load losses so that this can happen. Now tell me guys, if this has to happen, what's the ratio? What's the ratio of core losses to the copper losses, or full load copper losses to be more precise? If it has to be at 50%, I want efficiency to be maximum at 50%. Tell me, in that case, what should the ratio of core losses to the full load copper losses ratio, so that the efficiency will be maximum 50%. That's a task for all of you guys. Give it in the comment, your answer. Let's see how many of you answered it correctly. Okay. Core loss is not a function of secondary current. Amazing. Hence, they are less. And that depends. If we're talking about distribution, so we'll design it like that. If it is power transformer, the equation could be something different. It's not true for any transformer. It depends on you, the designer, man. You are designing it like that. Okay. Anyways, yeah, guys, correct. Now, to wind up, ask me guys if you have anything to related, maybe or regarding your preparation or whatever it is. If some question is there regarding TSGENCO, you may feel free to ask. I would like to clarify for a minute. Or if you have any queries on the questions what we discussed, you can ask. I would like to answer. I would like to take up those questions. If no such things, we're happy to end the session by saying happy birthday to Volta. Come on, Teja, don't guess. 1:2 cannot happen. So it seems no more questions, guys. Thank you for joining me here. Have a good time. Bye-bye. See you later. Khatam.